Bright Duty. Every student matters.
Right? How kinetic energy is dependent on two factors. Let us see a few questions based on this particular formula. Now let us see what exactly the question is saying. An object of mass 15 kilogram. The mass of the object is given to me to be 15 kilogram, is moving with a uniform velocity of 4 meter per second. The velocity is given to be 4 meter per second. Now since we are being given it is a uniform velocity, that means initial and final, it is one of the same thing. It was initially also at 4 meter per second, now also 4 meter per second. So it's normal velocity that is given to us in the question. We are just required to calculate the kinetic energy, and we know that the formula of kinetic energy is half mv square. Just putting the values, 2 multiplied by mass is 15 kilogram multiplied by v square is 4 meter per second whole square, comes out to be 1 by 2 into 15 multiplied by 4 into 4, cutting it with 2, I will get what, 30 and 120. This is the kinetic energy and this will be 120 joules answer. Simple. Clear? Fine. A very simple question. Let us see one more question. Now in this question what is being asked to us is what is the work to be done? What is the work done to increase the velocity of a car from 30 km per hour to 60 km per hour? Now what exactly is given to us in the question is the initial velocity of the car is given to us, which is represented by small u. This is 30 km per hour. We know that we need to convert it into meter per second because of its SI unit, and for converting it we know that we convert and multiply it with 5 by 18. Simple, right? When I do it I will cancel it out, 6, that comes out to be 50 by 6, which is equal to 8.33 meter per second, right? Now the final velocity is given to us. What exactly is the final velocity? It is represented by small v. This is given to be 60 kilometer per hour. Once again we need to convert it. How? 60 multiplied by 5 by 18 meter per second. Now from where does this 5 by 18 came? If you have watched the earlier videos I have already told, but if you are watching this video for the first time, then in that case we know that kilometer per hour, 1 kilometer by 1 hour. If we need to convert it into meter per second, there are 1000 meters in 1 kilometer and 3600 seconds in 1 hour. Cancelling it out, I will get 10 upon 36, further reducing it, then I will get 5 by 18. Got it? And once again 10 and 3, I will get 50 by 3, which comes out to be 16.67 meter per second. Now this is the final velocity. Now if the mass of the car is 1500 kilogram, I am given the mass of the car m is equal to 1500 kilograms. I need to calculate the work done, right? Now the work done is to be calculated. We know what exactly is the work done. Work done is basically the amount of energy required to change the kinetic energy or velocity of the body, and actually this work done is calculated by the formula F into S, but we are not given F, we are not given S. So whatever we have derived, we came to the conclusion that work done was equal to m into v square minus u square by 2. If you remember above in the derivation, or we can also say that this work done is equal to mv square minus mu square by opening the bracket divided by 2. This can also be deduced as work done is equal to half mv square minus half mu square, right? Now actually what we have done is we have related it in a detailed manner, otherwise work done is equal to the final kinetic energy of the body minus initial kinetic energy of the body, or we can say that it is the change in velocity or kinetic energy of the body. So this all is one or the same thing. So first of all, what I will relate, I will calculate the initial kinetic energy with the formula half mu square, right, initial velocity. Then I will calculate the final kinetic energy with the formula half mv square, and then simply I will take the difference. So when I calculate the initial kinetic energy of the body, it is half mu square. Values I already know, half into 1500, and the initial velocity that came above was 8.33, and it is the square of it. When I calculate it, it will be cutting it 750 into 8.33 into 8.33. Now if I calculate, I will come to an answer of 52041.68 joules. You please do it and just counter check. This will be the answer we will be getting. This is the initial kinetic energy. Next, I will calculate the kinetic energy, but final kinetic energy. That is calculated by the formula half mv square. Again, half into m was the same as that of 1500 kilograms, multiplied by v was 16.67 whole square. Again, cutting it off, I will get the value to be 750 multiplied by opening the square 16.67 into 16.67. Calculation is a bit bigger one, but you need to calculate, and once you will calculate it, you will get 208416.68 joules. This is basically my final kinetic energy. Got it? Now if I need to calculate the work done will be the difference of final kinetic energy minus initial kinetic energy. Final kinetic energy, it was this value, initial was this value. Let us see, 208416.68 joules minus initial one is 52041.68 joules, and when I will subtract it, I will get a value of 156375 joules. This will be your work done in increasing the speed of this car from 30 km per hour to 60 km per hour. Clear to everyone? Good. Let us see the next question. Now in this question, what exactly we are being asked is the kinetic energy of an object of mass m moving with a velocity of 5 meter per second is 25 joule. The mass is given to be m only. The velocity is given to be 5 meter per second, and the kinetic energy is given to be 25 joule, right. So with this we can simply calculate what exactly is the value of m, but this is not what is being asked. What is being asked is what will be its kinetic energy when its velocity is doubled. Now we know that kinetic energy is represented as half mv square, and kinetic energy is directly proportional to the square of the velocity. So if the velocity is doubled, means it is made 2v, then the kinetic energy being directly proportional to the square will become 4 times of its original value, and 4 times means if the initial kinetic energy is 25 joule, then multiply by 4, it will become 100 joules when its velocity will be doubled. The next part says is what will be its kinetic energy when its velocity is increased 3 times. Same concept to be followed. Now if the velocity is increased 3 times, right, then kinetic energy being directly proportional to the square of the velocity. Squaring it up, we will get 9v square. Initially it was v square, so the kinetic energy will become 9 times of its original value. And if initially the kinetic energy was 25 joule, in that case now the kinetic energy will become 9 times. When it becomes 9 times, multiplying it with 25 joules, I will get 225 joules. I will get 225 joules. This will be my answer, right? So, these are a few questions based on kinetic energy. Please try to relate, do the derivation and the numericals yourself to have a better command over it, right? Third question, a battery lights a bulb. Describe the energy changes involved in the process. Now, when we light a bulb, we provide electrical energy to the bulb, right? Fine. So, when this electrical energy is supplied to it, we see that the light, the bulb glows. So, it is converted into light energy, and if you touch the bulb, then you will find that the bulb has become a bit hot. That is why we can say that there is a bit of heat energy also being produced. So, this electrical energy is being converted into light energy as well as heat energy. These are the energy changes involved in the process of lighting a bulb. And since this electrical energy is provided by a battery, in a battery there must be some chemicals, so that chemical energy is being provided, which produces electrical energy, which in turn is converted into light energy and heat energy. Got it? Let us see the next question. Certain force acting on a 20 kilogram mass. So, now in this question we are given the mass of an object which is related by small m. This is given to be 20 kilogram. Changes its velocity from 5 meter per second to 2 meter per second. From 5 meter means initially the object was moving at a speed of 5 meter per second, which is taken to be its initial velocity represented by small u, and that is given to be 5 meter per second, and the velocity is getting changed from 5 to 2. That means the final velocity, which is represented by small v, is given to be 2 meter per second. Calculate the work done. We have studied earlier that work done is given by the formula change in the kinetic energy of the body, and the kinetic energy is of two types. One is initial kinetic energy of the body and the final kinetic energy of the body. The formula for kinetic energy is half into mass into velocity. So, if we are calculating the initial kinetic energy, it will be half into m into u square. Final kinetic energy will be half into m into v square, right. So, the work done is change in kinetic energy, means it will be the difference of these kinetic energies. Now, first of all, we will calculate the initial kinetic energy, right. So, difference in kinetic energy will be final kinetic energy minus initial kinetic energy. Final kinetic energy and initial we will calculate out separately, or we can just put up same as half mv square minus half mu square. Taking half and m common, we will see half, m is given to be 20, v is given to be 2. So, we will take 2 square minus u is given to be 5, we will take 5 square. It comes out to be 10 multiplied by 4 minus 25, or 10 multiplied by minus 21, that comes out to be minus 210 joule. Now, this minus signs decrease, this minus sign relates that this is the work done in retarding, in slowing down. The force is acting in the minus, in the opposite direction. Got it? So, this is the work done in reducing the speed of the object from 5 meter per second to 2 meter per second. Clear? Let us see the next question. An object of mass m is moving with a constant velocity. How much work should be done on the object in order to bring the object to rest? Now we know that work done is equal to the difference in kinetic energy of the body. Kinetic energy of the body, it is the final kinetic energy minus initial kinetic energy, the difference in the kinetic energy, right? So initially it was moving with a velocity v. So the initial kinetic energy will be half mv square, and the final kinetic energy of this particular object is basically 0. Why? Because the object is coming to rest, therefore its velocity is 0, and anything multiplied 0 is 0. So the work done is simply half into mv square. The minus sign relates that it is the opposite force which is acting and making the body to stop. Got it? Let us see the next question. Calculate the work required to be done to stop a car of 1500 kilogram. The mass of the car represented by small m is given to us to be 1500 kilogram, moving at a velocity of 60 kilometer per hour. The initial velocity of the car represented by small u is given to be 60 kilometer per hour. We know that the SI unit of velocity is meter per second, and here we are given kilometer per hour. So it has to be converted into meter per second, and we know how. We are going to multiply it by 5 by 18. Why 5 by 18? This is the eventual outcome. We know that in 1 kilometer there are 1000 meter, and in 1 hour there are 3600 second. Cancelling it, I'll get 5 by 18, right? So this will be the initial velocity. Striking it again with 6, I'll get 3, and here I'll get 10. This comes out to be 50 by 3 meter per second, right? Now since we are stopping the car, so the final velocity of the car will be 0, which is represented by v. It will be 0. So we know that the work done is a difference in kinetic energy. Now once again, the final kinetic energy will be 0, as we have seen in the previous question above. So therefore it will be just the initial kinetic energy, that is half into m into u square. This comes out to be, by putting the values, half into 1500 into u square is our 50 by 3 multiply by 50 by 3. Got it? So if I just calculate it, it will be 1500 into 50 into 50 divided by 18, right? Cancelling it out or simply multiplying, we can just see that it comes out to be 15 into 5 into 5. I'll take 15 into 5 into 5 is 25, multiply by 10 to the power 1, 2, 3 and 4. I'll take it to be 4 divided by simply 18, right? Cancelling it out, 3 5 the and 3 6 the, we are left above with 125 by 6 into 10 to the power 4. Further dividing it, I'll get 20.8 into 10 to the power 4 joule. This is the approximate value I am telling. You will just take it into 2 decimal places, right? Approximately 20.86 or something. So this will be the work done by this particular object. Fine, got it? So it is just basically we need to remember that the work done is equal to the difference in kinetic energy. The final velocity of the body is 0 because we are stopping the car. Rest we are just simply putting all the values into it. Let us review once again what all we studied in this video. We talked about, first of all, energy. We talked about the sources of energy. We talked about how energy is related to work. What is the definition of energy? It is the ability or a capability of the body to do some work. Standard international unit is joule. Then the various types of energy, and under those we started with kinetic energy. We saw what is kinetic energy. It is the energy possessed by a body by virtue of its motion or speed. Then we just got to know the formula half mv square. We derived that formula. From where did that formula come from? Then we just talked about the factors on which kinetic energy depended, that is the mass and velocity, how it dependent on them, and a few questions based on them, right? So this is all about kinetic energy. I hope you have understood it all.